Okay, this is the fifth video in the series on reasoning and proofs, and it's called Postulates, Properties, and Proofs. Well, we're going to deal with a lot of information very quickly, but don't worry about that because you don't have to memorize anything, and it's not a lot to understand. You just have to learn to use these things. So before we start, here's an idea: 1 apple plus 1 apple equals 2 apples. Well, the suggestion is this is more about apples than it is about mathematics. But because, if you have 1 apple and 1 apple and you put them on the desk together, you'll have 2 apples. But if you eat 1 apple and then eat another apple, you'll have no apples. Or if you put 1 apple in a blender and another apple in a blender, then you'll have a bunch of applesauce, right? You have to define what apple means. You have to define what plus means. You have to define what equals means. And again, if you have 1 apple plus 1 apple and then you leave it for 10 weeks, you've got a pile of mush on the floor. All right? Or if you have 1 red apple and 1 green apple, do you really have 2 apples? Interesting questions. You've got to define some fundamental definitions and rules in order to say that this is true. Talking of rules, here's a rule that you all know: the sun sets in the west. But what does set mean? And who decided that should be called the west? All right? These are just rules that we all accept, and it just happens to be called the west, and so we all follow that rule. Midday is 12 noon, when 12 noon is 12 p.m., right? Why? Why is 12? Why is it not 10? Why are there 2 12 o'clocks during the day? Is this really the middle of the day? Is midday, is noon, is the middle of the day? We don't know, but we are all going to accept that as true. And these things called axioms. We don't need the proof. We just accept them as true. And then from that, we can move on and do more complicated things as long as we accept these as true. This is particularly true in mathematics. It's an axiomatic system. We have some basic agreements on some fundamental building blocks. We don't need to prove they are true. We just assume them true. All right. These are not things necessarily created by God. They are things we could have just made up. Like, why does a circle have 360 degrees? Is there a reason for 360? Yeah, well, there's a historical reason. Should we stick with it? Yes, no, maybe not, but we're all going to anyway. Why does a polygon have to have line segment edges? That's the definition of a polygon. Why is it the definition? Because it is. Let's just accept it, and from there we can move on. Within geometry, there's some even more fundamental agreements, axioms, that we call postulates, that refer to the relationships between different things. So it's not just fundamental ideas, it's fundamental relationships. We've got a list of 7 here. There are more, and I'm going to whip through these super quick. Okay. You don't need to memorize this like this. So there are through any 2 points, you got 1 line. Lines are straight and go on forever. With any 3 points, they lie on 1 plane. Imagine your screen you're looking at is 1 flat surface, 1 plane. These 3 points are in it. A line contains at least 2 points. Yeah, it can contain more, but it can't just be 1. 1 point doesn't define a line. You need at least 2. Same with 1 point or 2 points don't define a plane. You need 3 points to define a plane. If 2 points are in a plane, the line going through them is also in that plane. Okay, lines lie in planes. two lines intersect, they intersect at one point. If two planes intersect, they intersect at one line. Now, yeah, they don't have to be perpendicular, they can be on weird angles, but two lines will intersect at one point, two planes will intersect at one line. So here's another list that I found just on the internet randomly that has the same ideas expressed a little bit differently. So they've got 8 instead of 7, but still basically these are the 7 fundamental geometric postulates, and from these all our other geometric rules can be created. Well, not only from these, but also from some properties. So we've got some algebraic properties, and then we'll also find some other geometric properties. So these first 4 here are just your basic operations: addition, subtraction, multiplication, division. And you would have learnt these in algebra. The next 3, reflexive, symmetric, and transitive, help us do more complicated substitution. And then the substitution shows us that we can replace values. Okay, I don't think I need to explain everything, you can read it. These 3 here, reflexive, symmetric, and transitive, become really important, and there's corresponding properties in geometric sense as well. So in the geometric sense here, we've got lines and angles, line segments and angles, sorry. So if a line segment has a length, then it has a length, right? It's the AB is AB. Measure of angle 1 is the measure of angle 1. If you're calling it AB, it's AB for its whole life, right? If AB is CD, then CD equals AB. Okay, and if AB equals CD and CD equals EF, then AB equals EF. These ideas, reflexive, symmetric, and transitive, help us do mathematics, but really all we need to remember is if you call something by that name, it's that name forever, and then if it's equal to something else, then you can manipulate it. Yeah, you can write them as line segments and the measurements of the line segments, or as the line segment itself. If you use the measurement, it's an equal sign. If you use the line segment, it's a congruent sign. We've also got, if you're talking about the lengths of the line segments here, like in this left-hand column, then you can replace all those lengths with real numbers that you measure. And then we've had this one before: if A, B, and C are collinear and B is in the middle, then AB plus BC equals AC. Okay. And these two here work with line segments. They have corresponding ones with angles. So basically you can measure any angle, and any of these rules will then be true using numbers. But also if R is in the interior of another angle, then the two angles will add together to form the bigger angle. If you try and draw this, it'll make sense. Okay, with all of these, what can we do? Well, we can use them to prove other things and prove other rules in geometry. I'm going to make another video where I show you that that's true. I'll show you how we use these. Okay, see you soon.